All right, good morning, happy Thursday. As you can tell, I've worn the same outfit 3 days in a row. So, don't judge. All right, so today we're going to be factoring, so we're going to be the opposite. And we kind of talked about factoring when we started with distributive property. So remember with distributive, you start with an expression that looks like this, and then we distribute that out and we get 2x plus 8. Now we're going to take this and factor it, so it's kind of what you start distributive property with. So that's what we're doing today. The first thing we have to talk about is reminder of what GCF stands for and how we find that. So first thing, let's go back to like 6th grade and remind ourselves what factors are. A factor is the product of the two numbers that kind of make up a number. So if I said the factors of 12, you would tell me pairs of numbers that can multiply to give me those factors. So let's just do a quick review of a factor. If I wanted all the factors of 20, what numbers would you tell me they would be? Let's see. Andrew, what you got, buddy? All right. 1 and 20, 2 and 10, 4 and 5. Awesome. So those would be all of the factors or the numbers that make up our number that we're talking about. And we're going to do this in a minute with some variables as well. So we're just starting really basic with some numbers. GCF then stands for the biggest number that can divide these out. So we're talking about a pair of numbers and the biggest one they have in common. So again, let's go back to 6th grade real quick. And if I said, what is the GCF of 14 and 21? We are looking for the biggest number that can divide both of these. And so what would be my biggest number that can divide 14 and 21? Oliver? Fantastic. It would be 7. Okay, too easy for us here in this class. So we are going to go ahead and find our greatest common factors for monomials, or a number with a variable attached to it, one variable or more. Okay, so it's the same concept. We're still looking for the biggest number that can divide both things. So here I'm looking for 4x and 12x. First thing, let's focus on the numbers. I have a 4 and I have a 12. So if I just focused on that and said, what is the biggest number that can divide 4 and 12? What would you tell me? You would tell me 4. Now they both have an x in common as well, so that would also be a part of it. And my greatest common factor of these monomials would be 4x. Okay. Moving on to number 2, we have an 18a and a 20ab. So let's just again look at our numbers first. The biggest number that can divide 18 and 20 would be what? Callie. Yes, 2. Okay, and then I have an A and an AB. And the only letter that they both have in common would be that A. So my greatest common factor would be 2A. Why can I not include that B? Correct. B can't be combined or in the part of that because 18A does not have a B attached to it. All right, if it was me, I would pause it really quick, try the next 2 before I tell the answers. All right, number 3. 25x and 15xy. Again, let's focus on the numbers first, and let's find the factors for 25 and 15. What is the biggest number that can divide both 25 and 15? Let's see. Tyler, I haven't heard from you yet. All right, 25 and 15 can both be divided by 5. Then we focus on our letters, and what letters do they have in common, Tyler? Awesome, 5x. And that would be as much as we could do, okay? Number 4, again, let's look at these numbers. We have a 42 and a 14. This one tends to be a little tricky. What is the biggest number that can divide 42 and 14? Let's see. Savannah, what'd you get? All right, 14. And then looking at our letters, they have both M and N in common. So that would be our greatest common factor. If you have any questions on that, make sure you message me. And we are going to move on to just factoring the expression. And first we have to focus on our greatest common factor because that's what we're going to pull out of these. Okay? So factor again, it means what do they have in common? Let's pull out something they both have. So for number 1, we have a 3 and a 33x. What do they have in common? We could pull out this 3. Okay? I pull out that 3, and then we ask ourselves what's left over. So if I take 3 divided by 3, I get a 1, and 33x divided by 3 would give me 11x. and make sure you can't take anything else out of them. And the only other factor they would have in common would be 1. So I would be done with that one. Okay? If you want to pause at this point and try the next 3, I would probably do that since these tend to be a little easier. Looking at number 2, again, looking at our 4x and our 35, what do they have in common? Let's see. Mackenzie back there, what you got? Right, they don't have anything in common because 4 can only be divided by 1, 2, and 4, and 35 cannot be divided by any of them, and there's no variable. So we would say it is not factorable, or you cannot factor it. Okay? Number 3, again, pulling out our greatest common factor for 14 and 16. What is the biggest number that 14 and 16 can both be divided by? Let's go with Cassidy. Okay? We could pull out that 2, and once we pull out that 2 again, we tell what is left over. 14x divided by 2 would give me a 7x, and 16 divided by 2 would give me a minus 8. And again, look at it really quick, make sure there's nothing else because you do want to pull out that biggest factor. Last one, we have 24 plus 21x. Finding that biggest number that can divide both of them. Callan, what would you have? Okay, 3 can be pulled out of both. And then left over would be an 8 plus a 7x. Can't remember if there's a story. Of course there's story problems. All right, so the Keys family has saved $480 as a down payment for a new television. If X is the monthly payment for 1 year, the expression 12X plus 480 represents the total cost of the television. So this is just telling me how much I would pay for it at the end of my payments, which I pay for 12 months. How could I factor this out? Again, you're going to find that biggest number that can divide both of those. So I'll give you a quick minute to do that. All right. And if you factor them out, 12x and 480, hopefully you realize if you just kind of cover up that 0, we don't need calculators, mental math. 12 can go into 48. How many times? 4. Pull out that 12, and I am left with x plus 40. Is my math right? I hope so. Okay. All right. The garden has a total area of 15x plus 18 square feet. Find the possible dimensions of the garden. So for this one, it's a little bit tricky because you want to know how you get your area. So again, you have to kind of think of what do you do to find the area of something. If you know this is the total area, and I'm going to assume we're finding the area of a rectangular garden. So you want to think of numbers. Again, you would factor this out to see what kind of numbers or what pairs of numbers you could get. So 15x plus 18, what's the biggest number that can divide both of them? You would tell me a 3, which would give us 5x plus 6. Okay? If you have any questions on factoring, please make sure you ask. Otherwise, hope it makes sense, and I will see you tomorrow.